Okay, I want to take a look at the lab on correlation and regression since a number of you made errors, and I want to go through this. X is representing the number of employees who were absent, and Y is representing the number of errors on the assembly line. And I started your table and filled in the X and the Y columns, but we need to go ahead and fill in the remainder of the columns. And X times Y will be 48. I can get this to fill in for me. Come on, pen. 48, okay. 5 times 20, 0 times 9, 2 times 12, and 1 times 10. Now squaring the x's, we get 9, 25, 0, 4, and 1. Squaring the y's, we get 256, 400, 0, 576. Squaring the y's, that should be an 81. And 100. Okay, so if we add up the x's, we get 11. If we add up the y's, we get 67. Add up the xy's, let's see, 148 plus 34 is 182. Add up the x squares, 10, 29, 39. Okay, and then 256 plus 400 plus 81 plus 576 plus 100. Oops, this one's wrong. That should be 144. I knew something wasn't right. Okay. So, starting over to add that up, 256 plus 400 plus 81 plus 144 plus 100. It's 981. Okay, we're to calculate the value of R, and the formula for that is on page 679 in our book. Copy the nasty looking formula. Now N is the number of data pairs. 1, 2, 3, 4, 5. We have 5 data pairs. And square root of n sum of the x squares minus sum of the x's, that quantity squared, times n sum of the y squared minus the sum of the y's squared. Okay, so Rn is 5 times 182 minus 11 times 67 over the square root of 5 times 39 minus 11 squared times sum of the y squares, which is 981, times the 5 minus 67 squared. Okay, I'm going to simplify the numerator. I got 173, and in the denominator 74. Because both of these are inside radicals, I can just same radical, I can just join them together. Okay, so 173 divided by the square root of 74 times 416, and I get 0.986. So that's the answer for number 3. Okay, I'm going to graph the points. Some of you had trouble with this. see how high I need to go. I need to go up to 20. So I think I'm okay. 16, 18. Okay, so I've got a list here so I don't have to flip back and forth. So our first pair is 316. 316. Okay, our second one is 520. 520. All right, 09. 212 and 110. 10. Okay, it looks like they're in a line, so I'll say yes. Okay, now I'm on page 678 in the book. In sum of the xy's minus the sum of the x, sum of the y, over n sum of the x squared minus the sum of the x quantity squared. And this is going to be the slope. The b-intercept, or the y-intercept I should say, will be b sum of the y's minus a times sum of the x's divided by n. And again, n is 5. Okay, so I'm referring to my totals that I got on the previous page. So a is 5. The sum of the xy's is 182 minus 11 times 67 all over 5 times the sum of the x squares, 39, minus the sum of the x's squared. Okay, so let's get our slope. 5 times 182 minus 11 times 67, getting 173. 5 times 39 minus 121 is 11 squared, 74. Let's write that as a decimal. Divided by 74. I'm getting 2.34 for the slope. Okay, so our b, sum of the y's is 67 minus a times the sum of the x's over 5. All right. I'm getting 41.28. When I do it with the more exact number, minus 2.34 times 11, 41.26. Okay, if you use exactly what I have there, divided by 5, so I'm getting about an 8.25. So our y hat, or y prime, what they use here is 2.34x plus 8.25.